Hello, welcome everyone. Welcome to the session on dependency injection in Rust. So, my name is Jiten Palaparthi. I'm a technologist. I do consulting as well as I also provide corporate trainings, uh, particularly precisely corporate trainings on Golang and then Rust. I have delivered more than I think 400 to 500 trainings in this Golang and Rust, microservice architectures, Kubernetes, Kafka, DevOps related things. All these trainings I provide, and I also work as a consultant, as I said earlier. So, coming to the session today, we are going to discuss about dependency injection in Rust. Very fascinating concept, very heavily used in most of the frameworks we have been using for the past many years. Is one of the very prominent design patterns, which is called dependency injection. So before going to jump into the example on in Rust, let's have some basic understanding of what dependency injection is. So dependency injection is a design pattern. Of course, there are many design patterns. It is one among the design patterns where a class or a struct, a type basically, does not create dependencies by itself, but instead the dependencies receives from the outside. That means the dependencies are injected from the outside. What is the benefit of that? This makes the code more flexible, easier to test, and then maintainable. Okay, that means the dependencies in your code are injected from outside. It's what the dependency injection is. Why dependency injection in Rust? Uh, Rust doesn't have any traditional classes like Java, C Sharp kind of. Rust has got structs and then traits. Rust doesn't have inheritance, multi-level or multiple, whatever it is. So the concept of dependency injection, you can still apply it in Rust by using Rust traits on Rust structs. So what we do is we don't hard code the dependencies. That means if you hard code dependencies inside your code, your code is not maintainable basically, not very flexible. Instead of that, we inject those dependencies through functions or something through functions actually. We inject those dependencies. What is the benefits of dependency injection? Basically decoupling. Decoupling means you are going to release the uh, tight integration between components. It is going to decouple uh, the dependencies. It is good for system should be more modular, and then it's pretty easy to maintain. Okay. Testability, mostly testability frameworks, testing frameworks, they require a lot of mocking, or stubs are very much required for testing frameworks. This dependency injection, it's one of the very famous uh, component. It's very famous pattern. Okay, to write testable code. Okay, flexibility, swapping out the implementations or configuring components. Uh, okay, to in order to scale your application or adapt your application to different implementations, dependency injection is very famous one. Maintenance, of course, changes are inevitable in any software. uh, if you properly design your application or a framework in such a way that uh, if you properly use dependency injection design patterns, so there are less it is less likely to impact other components in your code, because the components are decoupled, and then the dependencies, instead of having hard coding the dependencies, you are injecting dependencies into your code. That's what actually you are going to do. So two things that we have to uh, have we have to really discuss about dependency injection. There is a dependent object and then there is an independent object. These two things. And the other aspect or other benefit of dependency injection is inversion of control. Inversion of control is very, very famous. Inversion of control containers are there. One of the best example of very successful inversion of control is Spring Boot applications. It heavily use dependency injection. Dependency injection is one of the components of inversion of control. Okay, inversion of control, inverting something. Generally the application has got the control. The flow of your application logic is based on the application, but you are inverting the control. Instead of the application flow has got the control, the dependency object will get the control. There is a container that contains the container holds the dependency object. As soon as you inject that particular dependency object, uh, the dependent object will take the control of your application. That is what basically inversion of control does at a high level. Okay, let's go and then do a simple example in Rust for dependency injection. So cargo new dependency injection. This is an example. I would like to add this particular dependency injection example over here. Okay. What I do is traits are precisely used in dependency injection. As I said earlier, Rust doesn't support multi-level or multiple inheritance. So we have to create a trait. Again, I create a trait called ice shape. This ice shape trait, I create a function called area. It's going to be self and it's going to return F32. It's pretty simple. I don't want to go with the two functions. I want to focus more on dependency injection rather than this functions implementation and then having the clumsy code. So here what exactly I want to do is I want to create actually types. The type is struct rect. Rect is a type. I have L and then breadth, and then I would like to implement this shape for rect. So how do I implement IMPL I shape for rect? We already well aware of that. Area is going to return self.l into self.b. Simple implementation. I'm going to get the area. So there is a trait and there is an implementer for this particular trait. There is a type that I have created that's going to implement the trait. So what I would like to do is I would like to create a type, sorry, a struct called shape. This shape object I would like to develop in such a way that it should have a method. It should have a method. What I do is first I have to create the instance of the shape object. I can have a instance of a shape object. You can have new instance and then it's going to return a shape. Okay, this is sorry. I cannot implement like this. I'm sorry for that. I have to implement over here. This is a shape struct. Then what actually this shape struct can have is it will have a rectangle. So it will have a rectangle. That means I would like to call the shape object with rectangle. This video can be little lengthy because I would like to explain as clear as possible. Cool. And then I would like to have a method impl shape. So a function called new function. How you gonna implement new function is you want to create a self object. You can also put shape here. So it gonna return what shape of R. That means there is a instance called R, and then there is a instance called here. And then I have something called area. It's a self. That means I would like to call this with the method. So I would like to print line area of area. I just put area. How can I get the area? Is self dot r dot area. This is a simple method. Area. I'm going to print the area. So there is a shape. Shape is depending on rect. Okay, shape is depending on rect. If the shape is not rect, I think you can't do anything actually in this particular code. This is a composition. If you are aware of composition, this is a composition. Now I what I do is I do R1, which is a rect equal to rect of L is 12.45 and then breadth is 13 point some value. And then I have let shape1, I just give as shape1 equal to shape of new of R1 and then shape1 dot area. I don't need even this trait here. Okay, you can keep the trait. I don't. Oh, sorry. I don't need a shape. I don't need a trait here. Okay, I will. For now, I will comment this code. I will implement impl rect. I will implement this particular code of rect. This is how I do. I'm going to get the area of particular shape one. Okay, so cargo run cd dependency injection cargo run. This is going to print the area of that particular shape. But the problem with this code is, let's say I want to do it with a square. Okay, so what I do, I create a another type called square. Uh, Let me create it as a unit struct. So what I can do, I can have f32 and then I implement this method of square over here. I don't know why it's giving. I go and implement this particular method. So self dot zero, you know that it's kind of a tuple. So first argument, there is only one argument. It's called self dot zero into uh, self dot zero. So I want to pass this square to this shape. I want to get the shape. So the problem here in this particular code is this code is the dependent object. The dependent object is rect. So what you have to do, you may have to do r square. You may have to do something like this. Sorry, r1 maybe s square. However, the shape again, the shape should have two arguments. Then s is maybe s, something like this. Okay, here you have to pass again s as well, square. So ultimately what happened is the code looks pretty unmanageable. You know, this is not the way actually. This is, you may do it, but this is not the way exactly the good architecture looks like. Okay. Again, you have to write then area of rect, and then again you have to write maybe area of square. This is how you can do. Not only that, whenever you are creating the instance, you are forced to create two instances over here. So let maybe s1 which is called square, and then I have squares. I have, since it is a unit rect, square of maybe 34.56, and then here you have to pass square as well. Okay, s as, sorry, uh, shape.new, and then shape1 dot area of rect you have, and then this one, your first, the new has got two arguments, and then the s is square. S is s1. I don't know why it's use double quote instead of that. Yeah, r1 dot s1. This is what actually you do. Like that, your code has, you have to change everywhere in your code. Basically, this is what actually the problem with this particular approach. This is the problem with this particular approach. So what we do is we'll change the code with respect to dependency injection. Instead of writing this kind of code, we will try to re-implement it with respect to the dependency injection. I'll just keep the code like this. So you have the code. Uh, Let me comment this. This is required. Okay, let me comment the every code. Okay, till here. This is also I have to comment. Here also, if you want, actually you have to give shape1 dot area of square. That's how you can call. Now what I do is, let's do it in a better way, by you embracing the dependency injection way of doing things. There is a trait. Trait is better for design, and then there is a rect. I have to implement trait for the rect. What I do, impl I shape for rect. I don't know, I'm just rewriting the code. Fine. impl I shape for rect. Okay, you may lose the code here. And then impl I shape for square. See that there is in this trait is implemented right now. The trait is implemented for rect, and also for square, and also for square. Okay. Now I go and then implement this particular part. This is the key area. This is very key area. So here the argument should be, basically what you can do is, the argument, whatever the argument that you are passing over here, it should accept the a dependent object. The shape is the independent object. Whatever the object that you create on shape is an independent object, and then there should be a dependent object. You have to create a dependent object. So what I do is I create a s. Maybe I give it as a independent object. I give it as maybe t. I give right now the object whatever I give here. It could be dyn of I shape. This I can do. But one of the problems here is, whenever you implement reference, what you have to do is you have to maintain the lifetime. So maintaining lifetimes means there is some more code, but I also would like to explain you how to use actually the how to use the objects, how to use the box. Boxing is something that I would like to explain it to you. So what I do here is, exactly what I do here is I create a box. There is a box. Box is a smart pointer. There is a box. This box is going to have I shape. This is a smart pointer. Box is a smart pointer. Cool. And then when I come to this implement shape, okay, how do you inject the dependent object? You have to inject the dependent object. There are different ways that the you can inject the dependent object. One is through a in generally Java kind of a class methods dependent object. You can inject with set methods. Dependent object you can inject. You can also inject with a constructor. Dependent object injecting with a constructor is a very classical way, but in Rust there are no constructors. Generally, the idiomatic approach of Rust is using a new function is like a constructor. You have to think new function is kind of a constructor. It's an idiomatic approach. That's what I'm telling. It's an idiomatic approach. So you pass t and then you have is t. Okay, and what you have to do here is you have function area, which has got to be a self. It's gonna print the print line area equal to self. That means that particular object dot t. This is t. This t has got area method because this t is nothing but the box of smart pointer of I-shaped trait. That means any object that implement the shape can use it. Any object that implement the shape can use it. This is one way of doing it. So what you can do over here is I create shape and then I call R1. So R1 is it is expecting a smart pointer. It is expecting a smart pointer, but R1 is not a spot pointer. R1 is a reference. It doesn't accept even the reference. So what you need to do is you need to create a box. Okay, you have to create a box. This is box. You can pass one. Here also you can create a box, new box. That means new spot pointer you are passing over here. So shape one dot area, and if you want actually let shape two equal to shape of new of S1, then shape 2 dot area. You see that the implementation is same, but actually there is an injecting object. R1 and S1 are injecting objects. This is a dependent object. Remember that here R1 is a dependent object, S1 is a dependent object. We are injecting this independent object into shape so that internally shape call this area method. This is what actually dependency injection. This is a dependency injection. So let me run the code. Cargo run. We can have area and then area of rectangle and then area of square, whatever it is. This is one way you can achieve the code by using dependency injection. Let's go and then achieve the code in another way by embracing uh, uh, what do you call, we can also go and then use the generics way of doing things. We can also implement it by using generics. Okay, we will also, I would like to explain that as well in this video. So cargo new dependency injection generics. So I gonna add this particular folder into my workspace. I don't want to write the whole code again. So what I do, I copy the code and then I paste the code over here. Now you can do actually any way you can do, but there is a difference if you are using generics. If you are using generics, the code is pre-compiled already. There is a video on static dispatch and dynamic dispatch. You can have a look at that particular video. If you are using generics, actually what happened is it is a static dispatch. If you are using traits or with using box or reference of D1I reference type, it's going to do the dynamic dispatch. Any approach you can take. Okay. Basically, I follow this approach. There is it. I follow this approach. I feel like it's more clean code, uh, but it depends on actually. Both the approaches are okay, but the implementation is little different. I come to shape here. What I have to do is this would become the T. The reason it become T is I'm going to use shape as T. T is what actually I shape. So this T is I shape. As soon as you implement T with this particular I shape, what it expect is you have to pass this. Even when you are implementing it, it expect you to have a T. Okay. This is how you are doing. So you can call where T is I shape. It expect you as shape, implement shape T, implement shape T. I think this is okay. It expects this as well. This is a quite this because of the syntax only. I am not that uh, favorite of this, but however, okay. However, you can call this. So you see that we are passing a generic T. We are passing a generic T over here. This is the shape struct which has got a generic argument type you have to give in this brackets. Of course, this is how you can pass generics, and then this T is used. Any object that implement I shape can be passed as an argument over here. Then whenever you are creating an independent type, where T is I shape, you say that I don't want this kind of a syntax, you can also use this kind of syntax as well. I shape I shape of T. You can use this syntax or this syntax. I prefer this one. The reason is it is more verbose. So when you come here, this in this example, you don't need box because you are not using any box over here. There is no spot pointer. You are using generics. Okay, and even here you don't need to pass any box because you are not using any uh, generics. So this code cargo run is going to print this. So there are two approaches. One is through dynamic dispatch and one is through the static dispatch. Uh, so this is how actually you can implement a dependency injection. So dependency injection is heavily used in inversion of control. There are different things, and there are no constructors in Rust. So new is an idiomatic approach to create a new object, and then you can think it of it as a constructor. But there is no. It's a function basically. It's a function. It's a pure function. kind of a static function because you are calling it with the type, not with the object. So, so the R1 and S1 are dependent objects. These objects are injecting into this particular independent object, and shape is not really depending on rect or square. Shape is depending on a variable that implements this particular trait. Trait is very important over here. Okay, this is what about this dependency injection. This particular dependency injection it will help you to understand in any programming language, though I explained with respect to Rust. Thank you very much. Have a great day ahead.